All right, missiles, not exactly the first thing that comes to mind when you think exciting, right?
Not usually, no.
But UT, and this is a big BUT, missiles are a huge deal in modern warfare, and the tech behind them is seriously mind-blowing. So think of this deep dive as your crash course on all things missiles. Maybe you've got a presentation coming up, or you're working on some defense project, or hey, maybe you just want to win a trivia night. Whatever your reason, we're going to break it all down for you. The different types, the science, even some of the most powerful missiles out there.
We're also going to tackle one big question that's been on everyone's mind. How's Russia's new Oreshkin missile changing the game? Is it really as unstoppable as everyone says?
Okay, so let's start with the basics. What exactly makes a missile different from, say, just firing a cannonball? I'm picturing myself lobbing a cannonball, and it's just going to fly in a straight line until gravity brings it down. So how is a missile different?
Well, the key difference is guidance.
Guidance.
A missile isn't just a projectile, it's guided. It can adjust its course mid-flight, making it way more accurate and effective than just launching something and hoping for the best.
So it's not just flying blindly, it actually has some kind of brain guiding it.
Exactly. It's got a brain, so to speak. To break it down further, a missile has four main parts: propulsion, guidance, warhead,
Yeah.
and control.
Okay, let's unpack those. So propulsion, I'm guessing that's the engine, right? What kind of fuel powers these things?
Most missiles use rocket engines, and they can run on either solid or liquid propellant.
So like is solid fuel like a giant firecracker?
Yeah, think of it like a huge firework. Simple, reliable, ready to go. Liquid fuel, on the other hand, is a bit more complex but gives you finer control over the missile's flight path. Kind of like the difference between stomping on the gas pedal versus having more nuanced control over your speed and acceleration in a car.
Got it. So it's a trade-off, quick and simple versus more control. What about guidance? This is where things get really interesting, right?
Hmm.
How does a missile know where to go?
Guidance is the brains of the operation, you could say. Some missiles use GPS, like you have in your phone, to figure out their location and navigate to a target. Others use something called inertial navigation, which is like a super advanced compass.
I'm picturing a tiny, perfectly balanced gyroscope spinning inside, keeping it on course no matter how much it twists and turns.
That's a great way to visualize it. Then you've got missiles that use radar or infrared tracking. These are the heat-seeking missiles you see in movies. They lock onto a target's heat signature and chase it down.
So some missiles are basically predators, hunting down their targets. That's
It's
wild.
very real. And the technology behind it has come a long way. These systems are incredibly sophisticated.
Okay, so we've got the engine and the brains. What about the warhead? That's the part that actually does the damage, right?
Exactly. The warhead is what the missile delivers to its target. It can be
Mm.
anything from conventional explosives to,
Ugh.
well, let's just say there's some more concerning options.
I'm guessing nuclear warheads fall into the concerning options category.
Yeah. Nuclear-tipped missiles are the most powerful weapons ever created, capable of unimaginable destruction. But the good news is that their use is very tightly controlled internationally.
Let's hope it stays that way. Okay, last but not least, we have the control system. What does that do?
Think of it like the steering wheel. It uses fins, wings, even something called thrust vectoring to keep the missile stable and on course. It can even allow for some crazy maneuvers, like dodging obstacles or taking sharp turns to avoid enemy defenses.
So we're not just talking about a straight shot. These things can literally dance around in the air. That's incredible. So we've got the basics down: propulsion, guidance, warhead, control. But I'm guessing there isn't just one type of missile, right? You've got missiles launched from ships, planes, submarines.
You're absolutely right. There's a whole world of different types of missiles, each designed for a specific job.
Okay, so how do we even begin to categorize them? Where do we start?
Well, there are three main ways to classify missiles: by where they're launched from, what they're designed to hit, and how far they can travel.
Okay, that makes sense. So first, where they're launched from. So you've got ground launched, air launched. What else?
You've also got missiles launched from ships and even submarines. For example, surface-to-surface missiles, like Russia's Iskander, are launched from the ground and hit targets on the ground. We've seen these used a lot in the conflict in Ukraine.
The Iskander, what's special about that one?
It's known for its accuracy and its ability to maneuver in flight, making it really tough to intercept. That's why it's been such a key weapon in the Ukraine war. It can slip past traditional defenses.
So it's a tactical weapon designed to get around enemy defenses.
Exactly. Then you've got surface-to-air missiles, like the U.S. Patriot system. They're designed to take out anything coming from the Skythink aircraft, even other missiles.
So the Patriot is basically a shield against air attacks.
That's a good way to put it. Now, moving on to air-launched missiles, we have air-to-air missiles, like the AIM-120 AIMRAAM. Think of those intense dogfights you see in movies. Fighter jets using these missiles to take each other out.
So like Top Gun, but with missiles instead of machine guns.
Pretty much. Then there are air-to-ground missiles, like the AGM-65 Maverick, which are launched from planes to hit targets on the ground with incredible accuracy.
So if you need to take out a specific target on the ground from miles away, that's your weapon of choice.
Exactly. And of course, you can't forget about the submarine-launched missiles. Specifically, submarine-launched ballistic missiles, or SLBMs for short. These are typically nuclear-capable and launched from underwater, which makes them a crucial part of a country's nuclear deterrent.
Okay, I'll admit that sounds a bit terrifying. A submarine could be anywhere in the ocean, ready to launch a nuke.
That's the idea behind nuclear deterrents. The fact that they're so hard to detect makes them a really powerful deterrent. One example is the U.S. Trident II, which can travel thousands of miles and hit a target with pinpoint accuracy.
So it's like a hidden ace up your sleeve, but hopefully one you never actually have to use.
Right. Now, let's move on to the second way to classify missiles, what they're designed to hit.
Yeah.
Like you said, they're missiles specifically made to take out tanks, ships, all sorts of things.
So it's not just about blowing stuff up. It's about having the right tool for the job. What are some examples?
Well, you've got anti-tank missiles, like the Javelin, which are basically a tank's worst nightmare. They're designed to punch right through that thick armor.
It's like a David and Goliath situation, but with a high-tech slingshot.
Exactly. Then you've got anti-ship missiles, like the Harpoon. These can be launched from ships, aircraft, or even submarines, and are designed to sink warships.
What makes anti-ship missiles so hard to defend against?
Their speed and the fact that they can fly really low, skimming the surface of the water, makes them incredibly difficult to spot and intercept. They're a major threat to even the biggest warships. And then, believe it or not, we even have anti-satellite missiles, designed to take out satellites in orbit.
Whoa, hold on. We're talking about space warfare now.
It's a reality. While there haven't been any big incidents involving these weapons yet, the fact that they exist raises some serious questions about the future of space and the potential for conflict beyond Earth.
Okay, launch platforms and targets covered. What about range? I know some of these missiles can travel insanely long distances.
Range is the third way we classify missiles, and it's a big deal when it comes to their strategic implications. Short-range ballistic missiles, or SRBMs, can travel up to 1,000 kilometers.
1,000 kilometers, that's still a huge itty-bitty distance.
It is. Then you have medium-range ballistic missiles, or MRBMs, which have a range of 1,000 to 3,500 kilometers. These can cover whole regions.
So those are more for controlling a specific area.
Right. And finally, we have the heavy hitters, intercontinental ballistic missiles, or ICBMs. These behemoths can travel over 5,500 kilometers, crossing entire continents. They're usually armed with nuclear warheads and are a big part of why countries don't want to start nuclear wars.
Okay, officially fascinated and slightly terrified by ICBMs. But how do you even make something fly across the globe and hit a target thousands of miles away? What kind of science are we talking about here?
It's quite a feat of engineering, to say the least.
Hit me with some missile science.
Well, it all comes down to aerodynamics and propulsion. Aerodynamics is all about minimizing air resistance, making sure the missile stays stable in flight.
So it needs to be sleek and streamlined, like a fighter jet.
You got it. The shape and design of the missile are crucial. Things like fins and control surfaces also help the missile adjust its course and stay on target.
So it's not just brute force, it's about finesse too. What about propulsion? You mentioned solid and liquid fuel engines before.
Right. Solid fuel is like a massive firework, pre-packed and ready to go. Liquid fuel, on the other hand, is more complex but gives you more control, kind of like a car engine. Both are designed to generate a huge amount of thrust to push the missile forward.
Got it. But what about guidance systems? It still boggles my mind how these things actually know where to go.
That's where the real magic happens.
Right.
We talked about inertial navigation, which is like a super accurate internal compass that uses gyroscopes and accelerometers to keep the missile on track.
Right, like that spinning top we were talking about.
Exactly. GPS guidance is also becoming more and more common. It uses satellites to pinpoint the missile's location, giving it incredible accuracy.
So it's like having a real-time map guiding the missile to its target.
Pretty much. And then there's radar and infrared tracking. These are what allow those heat-seeking missiles to lock onto their targets and adjust their course in real time.
So these are the missiles that can chase down moving targets. That's some next-level stuff.
It is. And the technology is constantly evolving, getting more and more sophisticated all the time.
Okay, so we've got the basics down. Missiles are incredible feats of engineering with a whole range of different types and capabilities. But now I'm wondering, how do they actually stay stable in the air? They're flying so fast. Wouldn't they just tumble end over end?
That's a great question. It all comes down to their design and those principles of aerodynamics we were talking about earlier. Think about a dart. It's designed to fly straight because of its shape and those feathers in the back.
Yeah.
Missiles are similar. They use things like fins, wings, and even their overall shape to generate lift and stay stable.
So just like a plane, a missile needs lift to stay in the air.
Exactly. And those fins and wings you see on many missiles act like the wings of a plane, generating lift and helping to control the missile's direction.
What about staying stable, though? They're going so fast. Wouldn't they wobble or spin out of control?
That's where control surfaces come in. These are small, movable surfaces on the fins or wings that can adjust the airflow around the missile. By making tiny adjustments to these control surfaces, the guidance system can keep the missile perfectly stable, even at supersonic speeds.
So it's like having tiny rudders and ailerons that are constantly adjusting to keep the missile on course.
That's a great analogy. And it's this combination of smart design and sophisticated control systems that allow missiles to fly with such incredible accuracy and stability.
So it's not just about raw power. It's about a delicate balance of aerodynamics, propulsion, and guidance. That's fascinating.
Absolutely. And the development of new technologies is constantly pushing the limits of what's possible in missile design.
So with all this advanced tech, who's making the best missiles in the world? It feels like there must be some serious competition going on.
It's a fiercely competitive field, with several countries vying for the top spot. It's almost like a global high-tech arms race, with each nation trying to develop the most sophisticated and powerful missiles.
Let's start with Russia. They're known for having some pretty powerful weapons, right?
Yes, Russia has a long history of developing advanced missiles. One of their most well-known systems is the S-400 Triumph, considered one of the most sophisticated air defense systems in the world.
What makes the S-400 so special?
It has an incredible range. It can target aircraft and missiles over 400 kilometers away. It can also engage multiple targets at once, and is highly mobile, making it very difficult to take out.
So it's like a mobile fortress in the sky, capable of swatting down anything that comes within range.
That's a pretty good way to put it. It's a very potent weapon, and its deployment has raised concerns in many countries.
What about Russia's offensive missiles? What are some of their standouts?
We've already talked about the Iskander-M, which is a tactical ballistic missile known for its accuracy and its ability to evade interception by making sharp turns during flight.
So again, designed to overcome enemy defenses.
Precisely. It really showcases the Russian focus on developing systems that can penetrate sophisticated air defense networks.
Okay, let's shift gears to the United States. What are some of their standout missile systems?
The U.S. has always emphasized precision and long-range capabilities. One of their most well-known systems is the Patriot PAC-3, which is specifically designed to intercept ballistic missiles. It's essentially a counter to missiles like the Iskander.
So it's like a shield designed specifically to stop incoming ballistic missiles?
Exactly. The Patriot is a crucial defense against attacks from countries like North Korea or Iran, which have been developing their own ballistic missile programs.
What about the U.S.'s long-range capabilities?
For that, they rely on the Trident II, also known as the D-5, which is a submarine-launched nuclear missile. It's incredibly accurate and can travel thousands of miles. It's a big reason why those stealthy submarines lurking beneath the waves are considered such a powerful deterrent.
Okay, so we've got Russia and the U.S. Who else is a major player in the missile game?
Iran has been making significant strides in developing its missile program, which has raised concerns for many countries in the region.
What kind of missiles does Iran have?
One of their most notable missiles is the Fate 313, a short-range ballistic missile known for its accuracy. While it doesn't have the range of some others, its accuracy makes it a significant threat within the region.
More of a tactical weapon meant for regional conflicts.
Right. They also have the Khyber-Shekan, a medium-range missile. The development of the Khyber-Shekan demonstrates how rapidly their missile technology is advancing.
So Iran is a force to be reckoned with in the missile arena. It seems like missiles are a key part of their military strategy.
Absolutely. Their missile program is a major factor in the geopolitical tensions we see in the Middle East today.
Okay, so we've got everything from tactical weapons to intercontinental ballistic missiles capable of spanning the globe. But I'm curious, How are these missiles actually being used in today's world? We're seeing it play out right now in the Ukraine war, aren't we?
Definitely. The war in Ukraine has really highlighted just how important missiles are in modern warfare.
In what ways?
Both sides have been using them extensively. Russia has used missiles like the Iskander to target key infrastructure in Ukraine, things like power grids, communication centers, and military facilities.
So they're using missiles to cripple Ukraine's ability to function and defend itself.
It's a key part of their strategy. And Ukraine has been using a variety of systems, including Patriot systems provided by the U.S., as well as their own missile systems, to try to defend themselves against these attacks.
I've also heard a lot about HIMARS lately. What are those?
HIMARS stands for High Mobility Artillery Rocket System. It's basically a truck-mounted rocket launcher that the U.S. has provided to Ukraine. It's highly mobile and can fire a variety of rockets, some with a range of up to 300 kilometers, which allows Ukraine to strike targets behind enemy lines.
So it's like a mobile artillery unit that can hit targets deep inside enemy territory.
Exactly. And they've been very effective at disrupting Russian supply lines, ammunition depots, command centers, really impacting their ability to wage war effectively.
So this back and forth exchange of missiles is shaping the entire conflict.
Without a doubt. It shows just how crucial missile technology is in modern warfare. Both sides are heavily reliant on missiles, not just for attacking, but also for defending and gaining a strategic advantage.
What about the Middle East? We've talked about how Iran's missile program is causing tension in the region. How is that playing out?
Iran sees its missile program as a key part of its defense strategy, a way to project power and protect itself from potential threats.
So they're basically saying, don't mess with us, or we can hit back.
That's the message they're trying to send. They believe a strong missile arsenal is essential for their national security. But other countries in the region see this as a direct threat, and it's led to a kind of arms race in the Middle East.
A tense situation with the potential to escalate quickly.
Exactly. The growing number of missiles in the Middle East is a major concern for global security. It creates a very volatile environment with a high risk of miscalculation or accidents that could spark a larger conflict.
Okay, time to talk about the elephant in the room. Russia's new Oreshkin missile. There are a lot of rumors flying around about this thing. Is it really as big a deal as everyone is saying?
The Oreshkin is shrouded in secrecy, but the reports about its capabilities are definitely concerning.
What do we know about it?
From what we've gathered, it's a hypersonic missile, which means it can travel at over 5 times the speed of sound.
5 times the speed of sound? That's insanely fast.
It is, and that makes it incredibly difficult to intercept. Most missile defense systems just aren't designed to deal with something moving that fast.
So what does that kind of speed mean for defense systems? Can they even react in time?
It's a huge challenge. By the time a radar system picks it up, it might already be too late to react. Plus, it's said to be highly maneuverable, making it even harder to shoot down. Imagine trying to hit a target that's moving at thousands of miles per hour and can change direction on a dime.
And what about its payload? What kind of warhead can it carry?
That's one of the big unknowns. Some experts believe it could carry a nuclear warhead, which would make it an incredibly dangerous weapon.
Okay, this is starting to sound like something straight out of a sci-fi movie. A hypersonic, potentially nuclear-capable missile that can dodge any defense system. That's pretty scary.
It's definitely cause for concern. The development of hypersonic missiles like the Oreshkin represents a significant shift in the global balance of power.
So what does this mean for the future of warfare? Can we even defend against weapons like this?
That's the million-dollar question. Countries are having to rethink their entire defense strategies because of these hypersonic missiles. It's pushing the limits of missile defense technology and leading to a focus on developing systems that can actually intercept these incredibly fast and maneuverable weapons.
So it's a new kind of arms race.
You could say that. The development of hypersonic weapons has everyone scrambling to develop countermeasures, which could lead to some big breakthroughs in areas like sensor technology, artificial intelligence, and even directed energy weapons.
It's like a constant game of cat and mouse, with each side trying to outdo the other. But what are the bigger implications of the Oreshkin? How could this one weapon change things?
Well, if it really lives up to its potential, it could give Russia a major military advantage, especially against NATO countries. And it could even destabilize whole regions as countries try to develop their own hypersonic capabilities to counter the threat.
So a potential trigger for a whole new arms race.
It's a real possibility. We're already seeing increased military spending and a renewed focus on missile defense because of hypersonic missiles. It could lead to a dangerous escalation as countries feel pressured to keep up with their rivals.
This is getting pretty heavy, but it's also incredibly fascinating. I'm starting to see why missiles are such a big deal in global politics.
They're a symbol of power, technological progress, and unfortunately also the potential for destruction. They represent the cutting edge of military technology and have the power to shape the future of warfare in international relations.
Okay, before we get too deep into the geopolitical side of things, I want to take a step back and talk about the science behind hypersonic flight. How is it even possible to travel at 5 times the speed of sound?
That's a great question. It's a huge engineering challenge, pushing the limits of aerodynamics, propulsion, and material science.
So it's not just about building a faster engine.
Nope, it's much more complex than that. At hypersonic speeds, the air around the missile behaves completely differently than it does at lower speeds.
What do you mean?
Well, at those speeds, the air around the missile gets incredibly hot and dense. This creates a lot of friction, which can actually damage the missile's structure and create a shock wave that can make it unstable.
So it's almost like flying through a wall of fire.
That's a pretty good analogy. To overcome those challenges, hypersonic missiles need to be built with special materials that can handle the extreme heat and pressure.
What kind of materials are we talking about?
They often use advanced composites, ceramics, and refractory metals, which have incredibly high melting points. These materials are chosen for their ability to withstand the intense heat and stress of hypersonic flight.
So it's almost like building a spaceship rather than a regular missile.
In some ways, yeah. The technology is actually very similar to what's used in space exploration, where spacecraft need to withstand incredible temperatures and pressures during launch and re-entry.
Okay, so they've got the materials. But how do they generate enough thrust to actually reach those speeds?
Hypersonic missiles usually use a combination of different propulsion systems. Some use something called scramjet engines, which are air-breathing engines that can function at hypersonic speeds.
Scramjet engines. That sounds pretty futuristic.
They're very advanced technology. Scramjets use oxygen from the atmosphere to burn fuel, which makes them more efficient than traditional rocket engines.
So they're literally sucking in air and using it to fuel their flight.
Exactly. It's a very clever way to achieve those speeds without having to carry as much oxidizer on board, which would add extra weight and limit the missile's range.
Okay, materials and engines, check. But how do you even control something flying that fast? It seems like it would be incredibly unstable.
Controlling a hypersonic missile is a huge challenge. At those speeds, even tiny adjustments can have a big impact on its trajectory.
So it's kind of like trying to steer a car on an icy road.
That's a good way to put it. Hypersonic missiles need very sophisticated control systems that can react instantly to changes in the flight environment.
What kind of systems are we talking about?
They often use advanced algorithms, sensors, and actuators to constantly adjust the missile's flight path. Some even use artificial intelligence to make real-time decisions based on the information they're receiving.
Whoa! AI-powered missiles. We're really getting into sci-fi territory now.
It's a rapidly developing field. The use of AI in missile technology is only going to increase in the coming years, allowing these weapons to become even more autonomous and sophisticated. They'll be able to navigate complex environments and evade defenses even better than they can now.
Okay, that's a lot of missile science to process, but it's honestly way more interesting than I ever thought it would be.
I'm glad you're enjoying it. Missiles are a fascinating subject, both from a technological and a geopolitical standpoint. They represent the cutting edge of human ingenuity and the complex realities of modern warfare.
Okay, we've covered a lot of ground so far. We've explored the basics of missile technology, the different types, the major players in the field, and even how they're being used in current conflicts.
And we've delved into the science behind hypersonic flight and the potential impact of Russia's new Oreshkin missile.
But there's still so much more to explore. We haven't even touched on the ethical considerations of missile warfare, the potential for arms control, or what the future holds for this technology.
We'll definitely be getting into those topics in our next installment.
For now, though, I think we'll leave it there. Thanks for tuning in to this deep dive into the world of missiles. Stay tuned for the next episode, where we'll continue our exploration of this fascinating and complex subject.
You know, we've spent a lot of time talking about the tech behind missiles, how fast they are, how far they can travel, the sheer power.
It's pretty impressive stuff.
It is. But it's easy to forget that these are weapons of war, and war always comes with a human cost.
That's a good point. We've been talking about missiles like they're just pieces of hardware, almost like something out of a video game. But these things have the potential to cause a lot of destruction, and real people's lives are at stake.
Every time a missile is launched, there's a risk of civilian casualties.
Yeah.
Even if it hits its intended target, there's always the chance of collateral damage.
Right. Homes destroyed, families torn apart, innocent lives lost.
Exactly. It's easy to get caught up in the technical details and forget about the human impact. We talk about things like strategic objectives and military targets, but behind those terms are real people whose lives are changed forever by conflict.
It's a sobering thought.
And what about the people who live under the constant threat of missile attacks? The psychological toll can be devastating.
I can't even imagine.
Imagine living in a city where there's always the fear of a missile strike, the constant anxiety, the uncertainty, the feeling of helplessness. It takes a huge toll on people's mental and emotional well-being.
It's a reminder that war isn't just about winning or losing on a battlefield. It's about the lasting impact it has on people, families, entire societies.
Exactly. And the ethical questions around missile warfare are really complex. There's so much to consider.
Like, when is it justified to use a missile? How do you minimize civilian casualties?
Those are some of the core questions that policymakers and military leaders have to grapple with. And there are no easy answers.
It seems like the more advanced missile technology becomes, the tougher those questions get.
Absolutely. The development of hypersonic missiles, for example, raises a whole new set of ethical challenges.
Because they're so fast and maneuverable, it's harder to guarantee that they'll hit only their intended target.
Precisely. The margin for error is tiny, and the consequences of a miscalculation are even greater.
It's a heavy burden of responsibility, knowing that the use of these weapons could have such devastating unintended consequences.
Which is why it's so important to have open and honest conversations about these ethical implications. We need to carefully weigh the potential benefits against the risks before using these weapons and think about the long-term consequences of our actions.
Okay, so we've talked about the human cost of missile warfare and the ethical questions it raises. But what about mitigating those risks? Are there any international agreements or treaties that try to limit the development or use of missiles?
There have been attempts to control the spread of missiles, but they haven't been very successful so far.
Why is that?
A big part of it is that many countries see missiles as essential for their national security. They see them as a deterrent, a way to protect themselves from attack and show their military strength.
So even if it means reducing the risk of conflict, they're hesitant to give up their missile capabilities.
Exactly. It's a tough balance to strike between maintaining national security and working toward global disarmament.
And the technology keeps evolving, which makes it hard to keep up with the latest developments.
It's a constant game of catch-up. As soon as one type of missile is restricted or banned, a new, more advanced version pops up.
So it's a moving target, which makes it hard to establish effective arms control.
That's true, but that doesn't mean we should give up on arms control. It's more important than ever to find ways to prevent the spread of dangerous missile technology and encourage communication and cooperation between countries.
What are some of the biggest hurdles to arms control when it comes to missiles?
Verification is a huge one. It's really difficult to monitor whether countries are actually following arms control agreements, especially with missiles.
How come?
Missiles are easy to hide, and the technology used to build them often has civilian applications as well as military ones. So it's tough to distinguish between legitimate research and development for peaceful purposes and the development of weapons.
So you can't always tell if a country is building a missile for a good reason or because they're planning to use it as a weapon.
Exactly. That ambiguity makes it very difficult to enforce arms control and ensure that countries are keeping their promises.
Okay, so verification is a big problem. What about trust? I imagine it's pretty hard to get countries to agree to limit their missile capabilities if they don't trust each other.
Trust is absolutely essential for any arms control agreement to work. And unfortunately, trust is often in short supply in international relations, especially when it comes to military technology.
So it's kind of a catch-22. You need trust to have arms control, but arms control is often seen as a way to build trust in the first place.
It's definitely a complex issue with no easy solutions, but we have to keep working towards building trust through dialogue, diplomacy, and a shared commitment to global security.
So are there any promising approaches to arms control that might actually be effective in limiting the spread of missiles?
One approach that's showing some promise is focusing on confidence-building measures.
What does that mean exactly?
It's about taking steps to increase transparency and communication between countries, sharing information about their missile programs, allowing inspections of missile facilities, setting up hotlines for communication during times of crisis, that kind of thing.
So it's about creating a more open and collaborative environment, rather than relying on secrecy and suspicion.
Right. By building understanding and reducing the potential for misunderstandings, you can create a more stable and predictable international environment.
Makes sense. If countries feel more secure, they're less likely to feel the need to build up their arsenals.
Another approach is to focus on regional arms control agreements that address the specific security concerns of a particular area.
Why regional agreements? Why not just focus on global treaties?
Because a lot of conflicts are driven by regional tensions and the spread of missiles within a specific area. If you can get the countries in a region to agree to limit their missile capabilities, it can help to lower tensions and prevent those conflicts from breaking out in the first place.
So it's about addressing the root causes of the conflict in that specific region, rather than trying to impose a one-size-fits-all solution.
Exactly. Regional agreements can be more effective because they take into account the unique political and historical context of that region and the concerns of the countries involved.
Makes sense. It's about finding solutions that work for that particular situation, rather than trying to force a global framework that might not be suitable for everyone.
And finally, it's important to address the reasons why countries develop missiles in the first place.
What are some of those reasons?
Often countries build up their missile arsenals because they feel insecure or threatened. They might be surrounded by hostile neighbors, dealing with internal conflicts, or lack other means of defending themselves.
So you have to recognize that developing missiles is often a symptom of deeper issues and address those root causes rather than just focusing on the weapons themselves.
Exactly. If you can create a more stable and secure environment internationally, countries are less likely to feel the need to develop and deploy missiles in the first place.
That makes sense, but it also sounds incredibly difficult to achieve. I mean, how do you create lasting peace and stability in a world where there's so much mistrust and conflict?
It's a huge undertaking, no doubt, but it's not impossible. It requires a multifaceted approach: diplomacy, economic development, and a genuine commitment to peaceful conflict resolution.
It's a tall order, but it's essential if we want to avoid the terrible consequences of missile warfare.
I agree. The stakes are simply too high to ignore this issue. We all have a responsibility to work towards a future where missiles are no longer seen as the solution to our security problems.
Okay, we've talked about the ethical challenges and the complexities of arms control, but let's shift gears a bit and talk about the future of missile technology. What's next? What new developments can we expect to see?
The field of missile technology is constantly evolving. We're on the cusp of some truly groundbreaking advancements.
Like what? Give me a glimpse into the future of missiles.
Well, we've already talked about hypersonic weapons, which are going to revolutionize warfare as we know it. But that's just the tip of the iceberg. Researchers are exploring a whole range of cutting-edge technologies that could fundamentally change how we think about missiles.
I'm intrigued. Tell me more. What kind of mind-blowing advancements are we talking about?
One area that's generating a lot of excitement is directed energy weapons. These weapons use lasers or microwaves to destroy targets.
Directed energy weapons? That sounds like something out of Star Wars.
It might sound like science fiction, but it's becoming a reality. These weapons offer a lot of advantages over traditional missiles.
Like what? What makes them so special?
For one thing, they're incredibly fast and precise. Lasers, for example, travel at the speed of light. You can't dodge that. They can also engage multiple targets almost instantaneously, making them really effective against things like swarms of drones or a barrage of incoming missiles.
So it's like having a super fast, ultra precise laser beam that can take out multiple targets at once.
Exactly. And unlike conventional missiles, which rely on explosives, you can actually adjust the level of force with a directed energy weapon, allowing for more controlled and nuanced engagements.
So it's a more flexible weapon. That's interesting.
Another exciting area of research is swarm technology.
Swarm technology, what is that?
Imagine a large number of small, autonomous drones that can work together to overwhelm enemy defenses.
So like a flock of birds, but with weapons. That's a pretty intimidating image.
It is. Swarm technology is still in its early stages, but it has the potential to completely change warfare as we know it. Imagine a swarm of hundreds or even thousands of these drones, each carrying a small explosive charge, all converging on a target simultaneously.
That would be almost impossible to defend against.
You're right. Traditional air defense systems are designed to engage individual targets. They'd be completely overwhelmed by a swarm coming from all directions.
It's like a hive mind approach to warfare. The collective intelligence of the swarm makes it incredibly powerful.
That's a great way to put it. And as artificial intelligence continues to develop, these swarms will become even smarter, able to adapt to changing situations and make decisions on their own.
Okay, I have to admit my head is spinning a little bit from all these futuristic possibilities. Bio-inspired missiles, nanotechnology, cyber warfare. It's like we're stepping into a science fiction movie.
It's an exciting time to be involved in missile technology, but it also comes with a sense of responsibility. These advancements could change the way we fight wars in a really big way, and we need to be ready for what that means.
So, where does all of this leave us? Are we headed towards a world dominated by robot armies and hypersonic cyber attacks?
It's impossible to know for sure what the future holds, but one thing is certain. Technology is changing the nature of warfare at an unprecedented pace.
And it's happening faster than most people realize.
Exactly. The advancements we've discussed, from hypersonic missiles to directed energy weapons, are only a glimpse of what's to come. As technology continues to evolve, we can expect even bigger changes in how wars are fought.
So, what can we do to prepare for this uncertain future? How do we ensure that these technologies are used responsibly?
We need to have open and informed conversations about the implications of these technologies. We need to involve policymakers, military leaders, scientists, and the public in discussions about the potential benefits and risks.
So, it's about bringing everyone to the table and having a dialogue about how to manage these powerful new tools.
Exactly. We need to establish ethical guidelines for the development and use of these technologies and make sure they're used in a way that minimizes harm and protects civilian populations.
And it's not just about preventing the misuse of these technologies, right? It's also about making sure they're used for good.
That's a really important point. These technologies could be used to solve some of the world's biggest problems, like responding to natural disasters or delivering humanitarian aid.
So it's about finding ways to use their power for good instead of just for destruction.
Exactly. The future isn't set in stone. We have the ability to shape it by making conscious choices about how we develop and use these technologies.
Okay, we've talked about the potential dangers, but are there any benefits to this technological revolution? Any silver linings?
Absolutely. While there are risks with any new technology, we have to remember that technology itself is neutral. It's how we choose to use it that matters.
So it's not about rejecting technology altogether, but using it wisely and responsibly.
Exactly. One potential benefit is that these advancements could make warfare more precise and less destructive overall.
How so?
Imagine a future where weapon systems are so accurate that they can target specific individuals or pieces of equipment without causing collateral damage.
So it's about minimizing the unintended consequences of warfare.
Precisely. This could potentially lead to fewer civilian casualties and a more humane approach to conflict.
That's an encouraging thought, but it also brings up some ethical questions, right? If we have the technology to target individuals with such precision, what's to stop it from being used for bad purposes?
That's a valid concern. It emphasizes how important it is to have clear ethical guidelines and international norms governing the use of these technologies.
So it's not just about the technology itself, it's about the values and principles that guide its development and use.
Exactly. We need to make sure that these technologies are used in a way that upholds human rights and respects the dignity of all individuals.
Okay, so we've covered a lot of ground. The technical aspects, the ethical challenges, the difficulties of arms control, and the potential for these weapons to change the global balance of power.
Been a really thought-provoking discussion, and it's clear that the future of missile technology is full of both potential and danger.
But before we wrap up, I want to circle back to the Oreshkin missile. It seems like this thing has the potential to be a real game changer. What are your thoughts on its impact on the global balance of power?
If the Oreshkin is as capable as they say, it's a very concerning development.
Why is that?
Its hypersonic speed and maneuverability make it practically impossible to intercept, and its potential to carry a nuclear warhead adds a whole new level of danger.
So it's a serious threat to global security.
It could be. It could embolden Russia to act more aggressively, knowing that it has a weapon that could potentially defeat any existing defense system.
And what about other countries? Could this trigger a new arms race?
It's already happening. The U.S. and China are investing a lot in hypersonic technology to try to catch up to Russia.
So it's that classic action-reaction cycle. One country develops new weapon, and everyone else feels like they have to do the same to protect themselves.
Exactly. And it's a dangerous cycle that can lead to increased tension and mistrust between nations, which ultimately makes the world a less safe place.
Is there anything we can do to stop this arms race from spiraling out of control? Is there any hope for a more cooperative approach to managing these powerful new technologies?
Dialogue and diplomacy are key. We need to find ways to engage with Russia and other countries that are developing hypersonic weapons, establish some rules of the road, and try to prevent misunderstandings that could lead to conflict.
So even with all this competition, we need to find ways to cooperate.
Exactly. We need to understand that we're all in this together. The development of new weapons, especially something as powerful as hypersonic missiles, affects everyone.
It's a reminder that global security is interconnected. What happens in one part of the world has an impact everywhere.
Absolutely. The development of these advanced missile technologies has huge implications for all of us, and we need to approach this with a sense of shared responsibility.
Okay, before we wrap up this episode, I want to leave our listeners with one final thought. We've discussed the potential dangers of this technology, but is there any hope for a future where these weapons are no longer seen as necessary? Could we ever reach a point where countries feel so secure and trusting of each other that they don't need to build and deploy missiles?
That's a really profound question, and it's a tough one to answer.
I know it might seem like a far-off dream, but is it even possible?
I think it's something worth striving for, even if it seems impossible right now.
But how do we even begin to move in that direction? What steps can we take to create a world where missiles are just a thing of the past?
It requires a fundamental shift in how we think about security. We need to move away from the idea that security is a zero-sum game, where one country's gain is another's loss.
So it's about recognizing that we're all in this together, that our security is interconnected, that what affects one nation affects us all.
Exactly. We need to find ways to build trust, reduce tensions, and resolve conflicts peacefully.
That's a huge task, especially given the current state of the world.
It is, but it's not impossible. It requires a collective effort, a willingness to talk to each other, and a commitment to finding common ground.
So it's about building bridges instead of walls.
Precisely. Real security doesn't come from building bigger and more powerful weapons. It comes from fostering understanding, cooperation, and a shared commitment to a peaceful and prosperous future.
That's a powerful message, one that I think we all need to hear.
I agree. The future isn't set in stone. We have the power to choose a different path, one that leads to peace, understanding, and cooperation.
Well, that's a hopeful note to end on. A future where missiles are a relic of the past. It's a future worth fighting for.
Absolutely. And it's a future we can achieve if we work together.
And on that note, we'll wrap up this episode of The Deep Dive. Thanks for listening, and we'll see you next time. It's amazing to think about how far missile technology has come. We've gone from those early basic designs to hypersonic weapons and AI-powered systems. Makes you wonder what's next.
You know, it's not just about making small improvements anymore. We're talking about entirely new concepts, things that could change how we think about warfare completely.
Okay, now you've got me really curious. What kind of mind-blowing missile tech are we talking about?
One area that's getting a lot of attention is the idea of bio-inspired missiles. Imagine missiles that can move and adapt like living creatures.
Bio-inspired missiles? That sounds like something straight out of a sci-fi movie.
I know, right? But scientists are already studying how birds and insects fly, looking for ways to apply those principles to missile design. Think about a missile that can weave through trees or dodge obstacles in a city with incredible precision.
That would be a game changer, especially in urban warfare or dense jungle environments.
Exactly. And then there's the potential for nanotechnology. We're talking about tiny machines built into the missile's structure that could allow it to repair itself or even change shape while it's in flight.
Self-repairing missiles, that's pushing the boundaries of what I thought was possible.
Think about a missile that can detect damage and automatically seal up any cracks or holes. It would make it almost impossible to stop with conventional defenses.
So it's like a Terminator missile, constantly adapting and repairing itself to finish its mission.
That's a pretty good analogy. It really captures the essence of what nanotechnology could do for missile design. And then there's the integration of cyber warfare into missile technology.
Cyber warfare, how does that work with missiles?
Well, we're talking about missiles that can hack into enemy systems, disrupt communications, maybe even take control of other weapons. It's not just about physical destruction anymore. Missiles are becoming digital weapons, too.
So the battlefield isn't just physical anymore, it's digital, too.
Exactly. Cyber warfare is a big part of modern conflict now, And missiles are becoming a platform for launching those kinds of attacks. Imagine a missile that could disable an entire air defense system with a single cyber attack.
That's pretty impressive and a little bit scary. It seems like the line between physical and digital warfare is getting blurrier all the time.
It is. And that raises a whole bunch of ethical and strategic questions that we need to figure out.
Okay, my head is spinning from all these futuristic possibilities. Bio-inspired missiles, nanotechnology, cyber warfare. It's a lot to take in.
It's a really exciting time to be following missile technology, but it also comes with a lot of responsibility. These advancements have the potential to completely reshape the way wars are fought, and we need to be prepared for that.
So what does all this mean for the future of warfare? Are we headed toward a world of robot armies and hypersonic cyber attacks?
It's impossible to predict the future with certainty, but one thing is clear. Technology is changing the nature of warfare at an incredible speed. And it's up to all of us to stay informed, have these important conversations, and work toward a future where these technologies are used responsibly and ethically.
Well said. We've covered a lot in this deep dive into the world of missiles. From the basic science to the geopolitical implications, it's been a wild ride.
We've talked about the different types of missiles, the major players, the ethical dilemmas, and the future of this technology, which is changing all the time.
And we've touched on some pretty mind-blowing possibilities like bio-inspired missiles and cyber warfare. It's been fascinating.
I encourage everyone to keep learning about this topic. The more we understand about missiles and their impact on the world, the better equipped we'll be to deal with the challenges and opportunities of the 21st century.
That's a great point. We've only scratched the surface here. There's always more to learn. Well, that's all the time we have for today's episode of The Deep Dive. Thanks for listening, and we'll see you next time. Until then, stay curious.